All right, good morning and welcome back. Today we're talking about another type of transformation. We're talking about reflections. Okay, so on Monday we talked about translation where it slides. A reflection, if we think about it, is more like it's you see it in the mirror. It says it's a transformation which the preimage and image are equidistant from the line of reflection. Okay, this line of reflection we can think of. This isn't like a technical version, but it's like our mirror. Now, you guys know as you walk towards a mirror, as you get closer to the mirror, your image gets closer. Okay, so in that case, you would be the preimage, your reflection is the image. Okay, what you see in the mirror. So let's take a look here now. It says reflect triangle ABC over the x-axis. First thing I want us to do is establish where is this x-axis. So hopefully you know your x-axis right here. So we can look at each of these points. Let's start with A. How far is A away from the x-axis? So 1, 2, 3, 4 away. So we have to go past that 1, 2, 3, 4. If it takes 4 to get there, we'll go 4 past. Okay. So now with B, to get to the line of reflection is just 1. So I'll go 1 past, and I'll put a dot right there. And that's B prime. Remember, we put the primes on it when it's the image, okay? So 1, 2 for C. So 1, 2 past. That will be C prime. And all we got to do to finish is connect the dots. And we are done. As you can see, if I would fold it on that dotted line, it would reflect, it would match up. Now, that's when we're reflecting over like the x-axis. The y-axis would be right here. It would have ended up over on this side. Those are pretty easy. Sometimes you're going to have to graph it over a different, like a line. So here, the line y equals -3. We want to practice graphing that. So what we do, on the y-axis, go to -3. Okay, so right here, on the y-axis, I'll go to that -3. And then it cuts through that line. Okay, so the line y equals -3. You might want to make a note. If it's y equals, then that means it is horizontal. It will cut through the y-axis at -3. So let's see, I'll draw this line. So in blue here, that's our horizontal line at y equals -3. Now the next one, it says graph the dotted line x equals 2. Okay, so I go to 2 on the x-axis, and I'm going to draw a dotted line through that because at x equals 2, that is where that will occur. Okay, so if we look here, I need to also say that that one is vertical. So it's kind of maybe the opposite of how you would think because it cuts through the x-axis. But if we think about it, every single point on this line, this is at 2, 0, up here would be at 2, 2, 2, 4, to -4. Every point on that has an x value of 2. Likewise, every point on this line has a y value of -3. So let's reflect this across the line y equals -1. So we need to start in red here. We'll draw the line y equals -1. So always, whatever's listed, we go to that axis. So on the y-axis, we'll go to -1. And then draw that line through. Okay, so that dots, the red line makes up the dotted line. Now we want to say how far is each of these away. So E is 2 away, so we'll go 2 past, and that is where E prime will be. Over here, L is 1, 2, 3, 4 away, so we go 4 past, 1, 2, 3, 4, and that is where L prime will be. D here is 1 away, so we go 1 past, that is where D prime will be. Then we connect our dots, and we are done. Okay, our next one, reflect across the line x equals 1. So once again, let's draw that line. So we always go on the axis mentioned, so the x-axis, go to 1. And let's draw in our line of reflection here in red. Now this one's a little interesting because some of the points are on the line of reflection. But let's start with the ones we know how to do, Z and H. So Z is 1, 2, 3 away. So 1, 2, 3 past. And that will be Z prime. Okay, likewise H, 1, 2. So 1, 2 past. And that will be H prime. Now, B and S are right on the line of reflection. Think for a minute. If you reach out and you touch the mirror, what does it look like is happening? Hopefully you guys know it looks like your reflection is reaching back and touching, right? So likewise, if you are touching the mirror, that is where the reflection occurs. So these points, since they are on the line, will stay there. I just need to relabel that as B prime and S prime because those points now are both B and B prime. The same point is both of those labels. Same point as S and S prime. And all I need to do now is connect my dots. And we have our reflection. All right. So our next one, reflect across y equals -2. So let's start by drawing that line. So once again, we'll go on the y-axis to -2, and we'll draw that line of reflection. Now, m is 1 below, so up to it 1, so 1 past. That is m prime. J is 1, 2, so 1, 2 past. That is J prime. D is on it, so that's going to be D prime. And we would be done. And our final one like this, it says reflect across the line, x equals -2. So we go on the x-axis to -2, and I draw in my line of reflection. Now this line of reflection does go right through the shape, so this will cause some differences here, but let's think about it. A is 2 away, so go 2 past. It'll end up over here, A prime. Now J is on the other side, but it's 1 away, so it'll end up 1 past on the other side. And likewise here, L is on the line, so it stays where it is. You can reflect both ways over a line of reflection. Okay? So I connect the dots, and now I got this weird spaceship thing, but we are done. Now, with lines of reflection, let's talk briefly about this idea of a line of symmetry. A line of symmetry is basically when you can draw a line of reflection through a shape, and if you reflect over it, it matches up equally on both sides. So for this oval, we would have a line of symmetry right there and another one right there. These are spots where if I fold it, it will match up. So it would be 2. Now this next one, this pentagon, there's an easy one right here. And many of you might think that's the only one. But think, if you turn your head and now you reorient it with the base here, we can also draw one through, oops, that's not my best. I gotta go through the point, but through there, which if you turn your head, you can see it folds there. You can go through each of the points through to the opposite base, okay? So there's actually going to be 5 lines of symmetry. And with our final one, the octagon here, we have 1 right there, 2, 3, 4. We also could go through each of these points. So 1, 2, 3, 4. Now that's 8 total. And obviously, I did not draw them perfectly. They all should have gone right through the center. That's human error, but hopefully you get the idea. All right, just about done with the lesson. The final thing I want us to talk about here is what do we do if we have a point and it's reflecting over the x and the y-axis? Sometimes we might not have a graph. Okay, we still need to be able to figure out what it is. So assuming we have just a generic point, x, y, okay, we're going to do this 3 times. Okay, so if we have this generic point xy and we reflect it over the x-axis. Now, I don't know, this is just an example, but if we had the point xy, so say it was over here, and so xy, we're also knowing though that point is at 3, 2, okay? Now if I would reflect over the x-axis, that would be right here. So it's 2 away, it'll be 2 below. So our point is still 3, 2. If we think about it in terms of xy though, the x value did not change, so it would still be x. The y value though is now the negative version. So it would become x negative y. Okay, so likewise, let's do it now. The same concept, except, oops, I don't want to delete all of that. I just want to delete it from the graph. Oh, this isn't working. I'll switch to my eraser. All right, so now the same concept, except let's take that point of 3, 2, or the xy coordinate, and let's reflect it over the y-axis. Now, if that's the case, the y-axis, hopefully you guys know, it's right here. So if we reflect, it's 1, 2, 3 away, so 1, 2, 3. That point would be at negative 3, 2. So from an xy standpoint, that'd be negative x comma y. The y value is the same, still the same height, but the x value switched. Now if it had been negative, the x value would still switch. It'd be the opposite, go to positive. Okay? Now the final scenario I want to talk about. This is a unique scenario. So watch closely. Let me get this fixed. Okay, what about the line y equals x? Now, if we graph this line y equals x, if we think about it, y equals mx plus b. So there's no b term, and the m here would be 1. So if there's no b, it's 0. It goes through the origin here, and it has a slope of 1. So if we draw this line in, if we look here, you can kind of think of it as it's like half a box away, so it'd go half a box past to right here. Now this original point was at 3, 2. The new point would be at 2, 3. So let's try another one. Over here, if that's at 2, you can see if we go diagonally, that's 1 away, so 1 diagonal past. That'd be over here at 0, 2. So I don't know if you're noticing a pattern. Let's do one more. What if I was at 4, negative 2? So from here, it goes 1, 2, 3. So 1, 2, 3. And that point, if it initially was at 4, 2, now would be at 2, 4. Okay, likewise, this initial point was at 2, 0, and now it's at 0, 2. Hopefully you can see whenever you flip over the line y equals x, the x and the y values switch. They just trade places. So as we wrap this up, it says 2, 5 is reflected in the x-axis. So let's look. If it's reflected in the x-axis, we know the y value has to change. So that would become 2, negative 5. All right, so now the next one. Negative 5, 0 reflected in the line y equals x. That's when they switch places. So it will become 0, negative 5. Negative 1, negative 7 is reflected in the y-axis. So y-axis here, we got to change the x value. So we'll get 1, negative 7. Now this final one, the only difference here is we have a decimal. It's the same thing though, reflected in the line y equals x. So we switch these and we get negative 8, 7.6. Okay, so we're just about done. Let me quick show you in Delta Math what we have to do on the assignment. So here it says graph the line y equals 2. Now remember the line y equals 2 will go through the y-axis. So if it goes through the y-axis, it would be horizontal. And now all I need to do is drag this down to go through y equals 2. Okay, and if I submit that, see, I got my check. Okay, this next one, what if it was asking us to graph the line x equals -1? So we know that'll go through the x-axis, so that would be a vertical line. And now I need to drag that over to -1, let it go, submit our answer, and yes, we got a check mark. Now the final type I want to talk about, this is pretty easy because the line's already drawn for us. We just need to plot it over that line. So right here, they're not labeled with names, but this is 1 away, so we go 1 past. This one likewise is 1 away, so 1 past. Now this one is 1, 2, 3 away, so 1, 2, 3 past. Okay, over here, 1, 2 to get to it, so 1, 2 past. And finally, 1, 2, 3, 4, so I'll go 1, 2, 3, 4 past. And as you can see, those shapes would match up and fold on that line. So we submit it, and at this point, we are done. If you have any questions, please let me know. Make sure you get the Delta Math assignment done. Have a great day.